Alright, so I'm going to begin by working through Chapter 4. Actually, 4.1 I'm going to separate into two parts for the videos. So the first part, Part 1, is going to be about angles and just describing how an angle is formed. And an angle is generated by rotating a ray about a fixed point, which we call a vertex, from an initial position to a terminal position. So let's see what that looks like by drawing a diagram. And if I start by making my XY axes, okay, and draw many of these, so you'll see them, not always the straightest, but so the vertex in our description is the 0, 0 point. So right where the X and the Y axis intersect, that is our vertex. That's the point that our rotation occurs on. So the initial position is going to be considered to be the positive X-axis. And let me just grab another color to make that stand out a little better. So the positive X-axis is when we go to the right on the X-axis. So this is the initial position. Our rotations begin from this point. Then they end somewhere, and we will consider that to be called the terminal position, where the rotation ends, okay? It won't just be in quadrant 1, but for Chapter 4 we're going to focus on angles in quadrant 1. Later we will move around the circle. So then our angle theta actually has started from 0 degrees here, rotated in this direction, stopped at a terminal position, and that's the angle in question right there, theta. Okay? So you probably noticed that I'm labeling the angle with a name that maybe you're not as familiar with, but often angles are given names that are Greek letters. So this is theta. That's the name of it. It's very commonly used Greek letter for angles. We will call angles theta. They can have other names as well, but theta is very common. All right, so the thing is too, we're going to have positive and negative angles. Positive angles. So positive angles rotate counterclockwise. All right, so as a diagram, let's look at that. So if this is my XY axis, they begin here and rotate up in this direction. And later we'll see that continues around like that, right? Negative angles then rotate clockwise. All right, that looks more like this. From the initial position, which is the positive X-axis still, they rotate this way. So let's have a look at an example with some numbers in it. This is my axes again. Make sure I have the right brush to write with. There we go. Here's my axis, my X and Y. How about if I have an angle that ends here? Okay, so the positive angle begins on the positive X-axis. So this is my initial side right here still. And the rotation is going to go counterclockwise. So around here, 90, 180 at this point, 270, And let's say this is another 15 degrees, so that's actually a positive 285 degrees. Okay, so we can also refer to that as a negative angle by rotating in a clockwise direction. So beginning on the positive x-axis, again the initial side, and rotating this way clockwise minus 75 degrees. So what you might notice is that 285 degrees and minus 75 degrees have the same initial side and terminal side. So they have a special relationship, then they are called coterminal. Alright, angles that had the same initial side and the same terminal side are called coterminal. They just rotate in different directions. So they are separated by any integer multiple of 360, which means if I take my 285 degrees and I subtract 360, so subtract means go back clockwise, so I subtract a full circle, I'm now back here. I'm at minus 75, so 285 minus 360 is 75. I could even subtract another 360 and end up, more negative. We're just looking at two coterminal angles right now. So that leads us to a formula for coterminal angles. Coterminal angles, alpha and beta, are coterminal if this formula holds true. So alpha plus n times 360 equals beta. And the restriction on this is that n is positive or negative integer. Okay? So this n, we must be doing full rotations of 360, not any partial rotation. N has to be an integer. 1, 2, 3, minus 1, minus 2, minus 3, and so on. And any integer multiple of 360 added to alpha will get us a coterminal angle. We're going to see later on, there's some interesting things about coterminal angles. For instance, when it comes to their trigonometric functions, they have the same values. Okay, so just so that everyone knows where I'm beginning the rotation of an angle, we use this term standard position angle, and I just think that it's important that everybody be clear what that is. So a standard position angle begins its rotation at the positive x-axis. Okay? And rotates counterclockwise. Alright, so if you see that described in a question on a test or by anyone else, the standard position angle, it actually begins like this. Alright, the x-axis is the initial side, the positive x-axis, and we will rotate counterclockwise. So that's a standard position angle. Okay, another important thing in this unit, just before I end this part of the 4.1, is plotting points. Just in case it's been a while or you're unsure about plotting points. X, Y. X first, then Y. So when I go to plot a point, say I'm plotting, for example, 2, 5. 2 is my X value, so we measure along here. 2 on the X axis, 1, 2, 3, 4, 5 on the Y, and it's the intersection of those two values. So over 2, up 5, and that's where the point gets plotted. We will be connecting that point to the origin in order to work with that rotation. So take that point, connect it back to 0, 0. You'll be concerned with the angle theta, which is created between the x-axis and that terminal arm. Okay, this should set you up for the rest of chapter 4, and look for part 2, which is about angle conversions, the rest of the topics in 4.1. Thank you.